So today we're here to talk about best practices for distributing componentized LabVIEW applications. So just to let you guys know who we have in the room. So we have myself. I'm one of the product managers for our software. So that includes package management. It includes System Link and parts of LabVIEW as well. We also have here Aaron Pena. He's from the R&D team, and for NI package management specifically, he's the product owner. And we also have a tech lead, Kent, over here as well. So if you guys have questions and things sound intriguing, or as deep as you want to go, come up afterwards and you can talk to us, all right? So once again, we're going to talk about the best practices for distributing. So what I'm going to do in this presentation is kind of set up the road to componentization, and then we're going to talk about specifically how you can use NI package management and this kind of technology that's pretty much built for distributing componentized applications. So let's go ahead and get started. So just as a quick plug, I'm going to go over a lot of things in this presentation. If you want to take a look at some details and just getting started and tutorials and tools and stuff like that, just go to bit.ly/NIPKG. And all this content, even this presentation, is uploaded there as well, okay? As well as the demo code put on GitHub. So everything I show you today, you can get your hands on. I think everyone's got it. Cool. So the agenda today. One is I want to, by the end of this presentation, I want you guys to be able to answer these questions. So one is, would my application benefit from componentization? Second one was, well, if the answer is yes, how do I then architect a componentized application? And then after I've architected it, well, how do I build that componentized application? And then, well, now that I've got the application, how do I distribute that componentized application? Okay. So there's been a lot of talk on componentization already here at NIWeek, some great technical sessions. So I'm gonna try my best not to overlap with that and point you to resources for the deep dive on those things. So let's talk about deployment strategy. So we've got there's the monolithic one. So maybe that's a picture that kind of conveys that. And then there is a componentized one. I think there was a presentation that called Lego blocks, right? So that's very fitting. So let's talk about what monolithic means. So monolithic deployment, what I mean by this is you've got your application that you see here on your left-hand side, and the actual deployment files are just the giant exe, right? So what does that workflow look like? Well, you're gonna create your code, of course. You're gonna create your exe build spec in LabVIEW, and then you're gonna build that all into a monolithic exe. Okay, and then after you do that exe, you're going to create a installer build spec, and then you would put that exe in your installer, and now you can put that installer on someone's machine. It's going to install your application as well as the runtimes and drivers and all that. So that sounds great. What happens if you have to now update something? Well, let me go and make modifications to my source code. Maybe all I'm doing is changing a constant, or maybe I'm just changing like the color or something, or like one small piece of the application. Well, then after that, you're going to have to rebuild the entire monolithic exe. So maybe that takes 4 hours. I'm not sure how complicated your applications get, but you have to rebuild everything. And then you have to rebuild that full installer, and then you would take that full installer and put it onto your new machine, which would basically reinstall everything, right? Chris?
Well, yeah, that you also have to revalidate the whole thing.
Yep. So if you're rebuilding the whole thing, then if you validated it already, you're going to have to revalidate everything, right? So that's an important thing as well. Thank you, Chris. I guess that's my last bullet that I forgot to talk about. Revalidate if necessary. Right? So how many people are doing this for deployment today? Okay, so decent amount. How many people are deploying code today, just in general? Okay, I would assume by the title of this that most people are doing that, or at least thinking about it in the future. Okay, so we got a decent amount of people doing monolithic deployments. So let's take that same application and let's talk about what a componentized deployment looks like instead. So if we look at the componentized deployment, now notice we've got the deployed files. We have an increase in the number of files. Let's kind of break it down. So what we have here is, in this case, I'm taking a look at my application, and well, I can divide that up into, I've got my top level application. I might have my modularized subpanels to kind of modularize my different UIs that are in there. I can also have plugin classes, right? So I might have a hardware abstraction layer, and I might support different pieces of hardware on different machines, right? So maybe each piece of hardware support could be a different plugin. I might also have config files, right? So depending on the machine I'm on, maybe I only need the config files for the DUTs that I'm testing, right? So you can take a look at your application and be like, okay, well, if I was to modularize this and be able to deploy things in multiple settings and update different things, how would I organize it? And this is kind of a pattern that we've seen, and I'm sure this might match up with some of your applications. So let me show you what that might look like. So if I go to my built, so the same screenshots that I took, I've got an EXE, I've got different panels in here. So these are packed project libraries. This is a little bit hard to see on the screen there. Let me see if I can change my view to project. Yeah, so I guess that doesn't help with the text. But yeah, suffice to say, it's the same thing that you saw on the slide. I'm going to double click my EXE, and in the subfolders, on other subfolders, I have some different plugins as well for hardware. So here we've got an application, and if you're looking at that, you could see that, hey, you know what? The way that I do this is I've got a hardware screen. So this screen down here could be one separate component, right? In this case, even within this screen, I can say, well, the hardware that's supported on this machine, we don't need to install, all 100 pieces of, all 100 support for all those pieces of hardware if I only am using 5, right? So in this case, each of these could be a component. And if I go to my sequencer, then I can see that, hey, well, over here, this whole entire UI could be another component. And then I can do view reports, and that can be another component, right? So this might be similar to some things that you're trying to do. You have some hardware, you might have some sort of sequence or something, you run it, and then sometimes you might have some sort of report or something like that, where you can maybe refresh and see what the new report is and view that. Right? So this is kind of a small scale application that might have things that are similar to yours. Okay, and then this whole frame here, so the thing that holds these different panels could be its own separate application, its own component as well. Maybe a very thin client or something like that. So let me go ahead and close this. Now that we kind of have an application in our head, and whatever you have back at work, maybe you map that inside your head. So that's what we got. Let's talk about, well actually, first a show of hands, how many people today are doing componentized applications for deployment? Okay, so less hands. So out of the people that aren't doing componentized applications today, how many would like to move to something that's more componentized? Okay, cool. So hopefully this will answer some of your questions and what your appetite. We can answer more specific questions afterwards too. So now that you decide that, hey, componentized deployment, that's something where I want to go, how do you architect your application to do that? So what I propose is ask yourself these questions then. So think about, well, how do I plan to push out updates to my application, right? So if you think about it, like, am I updating by adding more hardware support? Or are there different panels that I can imagine maybe I might want to change the way I view reports in the future, so maybe that's just a single update that I want to do. So think about what you want to update, and then also think about how does your end user want to update the application, right? So your application might be, 50 components, but from the user's point of view, like, what are the things that they're actually updating? And these questions might have different answers, but this will help you to construct the right way to componentize in the way that you distribute. Another thing to ask is, are there any pieces of your application that are reusable in other deployed applications? So is this view report or is this particular algorithm going to be something that's going to be used across applications? If so, maybe it makes sense to put that in its own separate component, so now you can reuse that component, right? And once you validated it here, you can actually use it in these other places as well. Okay. So just examples of components, it could be subpanels, it could be plugins for HAL and things like that, algorithm plugins, configuration files. So let's talk about some best practices then. As you're developing your application and you're thinking ahead, think about, okay, well, what's my UI look like? Is it kind of a master detail kind of thing? If so, then try to make each of those pieces of your UI modular and develop them separately. Okay, so in this case, I've got this shell for my main exe, and then I've created subpanels or separate VI for each of my subpanels that I'm going to load up in there. So if you don't know what subpanels are, just write that down and Google it. There's plenty of information on it, but that's how you would say, I have a different VI that I can now plug into a main viewer. Okay. Another thing is just modularizing your code in general. So if you have different algorithms that you feel like it makes sense to have this set be a component and this set be a component, or maybe each measurement is a component, you can do that as well. And that's just your good old libraries. And then you can also, what's great is you can use a plugin architecture. So what I mean by plugin architecture is you might have your main application sitting over here, And then by virtue of a plugin, what we're saying is you can just put the plugin code somewhere, and now this main application is going to be able to discover dynamically which plugins are available, and it will load them into the application. So what I have here is just the general principle here is this is kind of an example of how you do a plugin architecture with classes, but the plugin architecture can work with pack project libraries or source distributions and things like that. But the main thing I want you to remember is for a plugin architecture, generally what happens is you have some folder where your plugins are going to be installed to. And then what your main application is, which is this thing, is it's going to say, look at this folder. So that's what this code is here. It's going to interrogate this folder, tell me all the files in there that maybe are .lb class or whatever type of file you're looking at. And then there's code over here to say, now take each of those discovered pieces and load them into your application. Okay. So this is an example of how maybe if you had a hardware abstraction layer, this is how you would say, hey, let's look at this folder. Oh, there's 5 different drivers in there. I'm going to pull that driver support into my application. And when I say driver, I don't mean like the NI install driver. I just mean like your plugin to that was LabVIEW code to pull in that support. So let's keep going. So building a componentized application. So that sounds great in principle. What do things actually look like? So over here, notice that I'm going to put it into 3 categories. So one category is just your main exe. You need something that someone's going to double click and launch, and then it's going to be your actual main executable. And then I'm just saying there's a second class of just things I'm going to call plugins, kind of the stuff that I just described. So plugins can be either pack project libraries or source distributions or classes. And then over here we also have a third category of config files, which I kind of talked about earlier. Okay, so those are kind of the 3 main categories you can think about. So this is just going to be a quick slide. I'm not going to do the deep dive here. There's some really great presentations that I'm going to link to at the end of this. So which method should I use to build my plugin? There's kind of two main ones. One is doing a source distribution where you remove the block diagram. So they're VIs, but they're not really modifiable. And then there's also a pack project library, which is going to be a single file. Now, if you look on the screen, like physically, on your computer, this is what it looks like, right? And this is what one plugin would look like as a source distribution. This is what a plugin would look like if the same plugin maybe was like a pack project library. So just real quick, some of the pros and cons between each one. A source distribution, especially if you have like parent and child class relationships, it's just a simpler build process. There's less you need to necessarily get right. You can do that with a pack project library, but the process is a little bit more complex, and you have to make sure you follow certain rules. Another one that's kind of obvious from the graphic is if you want less files, then pack project libraries are better for that. Source distribution, you could say some of the source code is a little bit more exposed because I can read this and like, oh yeah, there's some read single point, there's read instrument descriptor. Whereas over here, you don't see any of that. It's just one file. It's kind of just one piece. Okay. Question?
Source distribution also has a weakness in that if your main executable doesn't contain a particular sub-VI that one of the source VIs requires, it breaks, correct?
I believe so. So rather than get into the deep dive here, what I'm doing is refer to the appendix, and like the appendix is going to have more slides. So I covered it last year in my presentation, but I want to make sure we have room for questions and for packages and stuff. And I thought I had. Yeah. So and I also have this slide. So if anyone wants more information on that, you can either take a picture, or I've also put this presentation on my GitHub, which I'll show you later on. So it's also on the bit.ly/NIPKG. So I'm just trying to put the knowledge as many places as findable. Okay. So yeah, to make those decisions and the step-by-step process of doing it each way, whether it's source distribution or pack project library, you can find it in these presentations. So thank you, community, for putting that up. So quick demo, to build the components into EXEs, PPLs, and source distributions. I'm just going to show you what that looks like in LabVIEW, kind of at a very high level. So one is, it's small, but this is just the main VI. I think everyone's familiar with, okay, well, I'm going to make a build specification, and that's going to be, my main EXE. So you would basically right-click here, go to New Application, and then within here you would say, the biggest thing is saying, hey, my main VI, I'm going to put it over here as my startup VI. And that's how I say, make this VI into an EXE. Okay. And then after you've done that, you can go ahead and click Build here, or you can just right click on the build specification and click build. And what that does is it's going to go to whatever directory you told it to go, and it's going to build these 3 files. So it's going to build a .exe and some files that go along with that. Okay. So that's my main exe. The next thing that you might want to build are your plugins, right? So in this case, let's go back to LabVIEW. This one is a source distribution. In this case, there's some fancy stuff that you can do with parent-child stuff, if that's what you want to do. That's going to be explained in the documents that I linked to, so don't worry, there's step-by-step for that. But what you're doing here is you're going to, if you choose that method for plugins, you right-click Build Specs, you go to New, you go to Source Distribution, and then what that looks like is something like this. So this is already pre-configured. You're going to say in the source files, okay, well, what am I doing? So in this case, I'm putting configure hardware as my source distribution. You can do things like, hey, make sure that this one is, oops. You can do things like, hey, make sure you don't include the block diagram. That way someone can't open it and just look at the source code. So there's a bunch of stuff you can do there. And once you've done it, you would click build. And what you would do for a source distribution, like you saw in the slide, you would see something that looks like this, where it's going to pull all those files into here. And that's what a source distribution looks like. So lastly, there's one for, let's look at this one. So this one is a pack project library. And a pack project library basically is just a regular LabVIEW library, but then you can compile it into binaries. So you get this one single LV-LIB-P file. So if anything, search Google LabVIEW PPL, and you're going to see a lot of stuff on it, as well as the presentations that we had this year. So for that one, you would just go right-click, go to New, and go to Packed Library. And then what you would get there is this build spec. And over here, what you want to do is you want to go to Source Files, you go find your library, and then you say, I want this library, run sequence, to be my top-level library that you build into a Packed project library. Okay? All right. So that was a quick run-through. Yeah, so I guess let me address this quickly then. So I'm saying the word source distribution. I mean, it seems weird. Like, how is a deployed thing called a source distribution? It has the word source in it. It sounds weird. But this is just one of the nuances with LabVIEW right now. So with LabVIEW, basically when you put that exe somewhere and you create something as a source distribution, if you have the runtime engine on it, then the exe is going to be able to look at that VI code and be able to execute it. Yes.
Separated.
Yes, and like if you want to be really safe, right, you can just when you make that source distribution, there's an option to remove the block diagram. That way, someone can't just double click on it and like start messing around with it.
How there's a setting in LabVIEW to separate the object code from the source code. How does that impact? I mean, if you select that, then the source code doesn't contain any executable object.
Right, but when you make that source distribution, you click build, like it'll have the information it needs to build it into a source distribution. Yeah. Okay, cool. Once again, this is where the details are. Like this goes through it step by step, so I would highly recommend reading this. And that could be a 2-hour presentation on its own. Okay, so now assuming that now you have the resources to figure out, okay, well, I'm going to separate this into exe and separate these into plugins, and now I have read about like which way I want to make my plugins. I choose one way. Now what you should get is now you've got your directory over here of all your different, so this is all my built code, right? I've got my source distributions, I've got my exe, I've got my pack project libraries, whatever it might be, okay? And it works, I've tested it. Now what I want to do is, I've got this componentized, I also want to distribute it in a componentized way. And that's what we're going to do next. Cool. Aaron, take it away.
All right. If I stand like this, can you hear me in the back? All right. So I'm going to talk a little bit about distribution using Package Manager, but I'm going to walk you through a good demo here in a second. But before we get there, I kind of want to go over some basics. First of all, when we say package, what exactly do we mean? Essentially, what we boil it down to is kind of 3 things, right? The first thing being, probably the most obvious thing being the installation file, right? This is your payload, this is your executable, your DIs, your whatever, GIFs, if you want to distribute GIFs for some reason. These are the things that you want to end up putting onto your end user's machine. The second thing being, and this is where packages really start to get powerful, is the metadata that you can surround your package with, right? So you can define what your package's name, version, who it is, the maintainer, all sorts of different metadata associated with it. And then probably the most important and the most powerful part of it is dependencies, right? So it's great that you can modularize your distribution, you can have a separate exe from your plugins, but if you don't know what depends on what and be able to say, oh, I want the exe, but I also want all the things that I need to be able to really use that exe, then it's really not worth a whole lot. So you can define, kind of what depends on what, and what those things depend on, the different drivers and different runtimes that everything needs to run. And we'll get into that here in a second too. So looking back at kind of the demo and the code that Alan was just talking about, of all the different components that we have here in this kind of demo project, we have a main exe, we have our plugins, we have our OWL kind of abstraction layers. Now imagine if all of those were separate packages, right? So all of these things can be packaged separately, all these things can be updated separately, and we'll go through all that here in a second. Now imagine you take an even step higher, because your end user may not want to know all these different lower level things. All they care about is, I'm testing this DUT, and I'm on test station 1, right? So that's all that they really care to know about. Now what you can do is create packages for those things too, and again, use dependencies to help define, if I'm at test station 1 and I have DUT, A001 that I'm testing, these are the different packages that I'm gonna need. Okay? So I'm gonna go through kind of the overview of how that'll all work out. So I'm going to jump back into basically the code that Alan was just looking at. And one of the other build specifications that we had that was kind of introduced a couple of years ago is now built into 2019, so you don't have to add anything on, you have to install anything in addition to LabVIEW itself, is the new package build specification. So we take a look at this and open it up. It looks very similar to all the other build specifications that we have already. You can define all of your different metadata, package name, where you want it to be basically built to, what things you want to include in that package, so basically what your payload is, like I said, the kind of the first thing on that list. In this case, we're including the application, that the exe, where those source files will end up on the user machine, in this case program files, shortcuts. And this is really where a lot of the meat of it comes in, is again, all that metadata I was talking about, where you can define package name, version, maintainer, all sorts of other things here. I won't go through all of these different things, but a lot of options there. And again, all the things that it depends on. So one of the things, like I said, that's really powerful is being able to say, I depend on this so that when you install me, you should also install this other thing. This is where you make those declarations, right? So in this case, the exe, since it's built in LabVIEW, is dependent on the LabVIEW runtime engine. These can be automatically kind of auto-detected and generated, or you can, by name, set a package that you want to depend on. And then additionally, kind of the usual things, you can version your packages, which is always a good idea. Give it different things like release notes and display versions, as well as schedule some custom actions that happen either pre or post install. Now, these other two I will talk about here in just a minute. So, we've already built these packages, so I'm going to show you kind of what it looks like a little bit. Pull back the curtain just a little bit. If we look in these packages folders, these are the packages from all the different projects that Alan just pulled up, all the different plugins, and the main application itself. The main application is this package here, comp demo, componentized demo, 200 Windows all NIPKG. In fact, I'm going to go back here a little bit more. I'm going to show you the guts of these things. Manager. So you'll see we have obviously package manager. For those who haven't seen it, we'll look at it in a little bit. But there's also a CLI that you can interact with. So if I go to there, I'm going to run a CLI. a command to basically unpack the package that we were looking at. So unpack this package, and we're going to unpack it to this folder, into a directory called unpack. Unpack it there. We'll see basically the three things I was talking about. In the data folder, we have our payload, which is our application, right? In our control folder, we have what we call our control file. So if I look at this with any sort of editor, basically what this is all the metadata that we defined for this package, right? So the package name, the version, its dependencies, some of the other attributes that are going along with it. So this is kind of what makes up all of the different attributes about this package. All right, so next thing. So we built all our packages. Great. Now how do we actually get them to the user, right? You could send them just a zip folder of packages and they have to click them all, double click them all. It's not super useful. What we recommend doing is there's something called a feed, right? So who's familiar with feeds at all? Who's heard that word this time around? All right, Shalina, what would you define as a feed?
It's a series of packages that I want my environment to be aware of.
Okay.
I'm sorry, let's just go pull the graphic.
Oh yeah. So we're looking at a feed. So basically, you're right. The way that I think about it is it's a collection of packages, right? And essentially, when you get down to the nuts and bolts of it, really it's a manifest, right? It's a manifest that says, hey, all these packages are related or they're basically collected into a feed. So the way that we handle that is this is also part of this package build spec. If you look down here, there's this feed section, right? So one of the functionalities that we have now is as you build this package, we can also say, hey, add it to a feed, right? And so basically what it's saying is if the feed's not there, create it. If it is there, just add it to it. And you give it the path to where you want the feed to exist. In this case, it's on a local drive that you retain. It could be on a network drive. It could kind of be really wherever you want. And then what that'll do is if we actually go to that folder and see what's in there, so it's this folder, you'll create these 3 packages files. Now these are really what make up a feed, right? This is the manifest. And if we look at that, all these are text files really, is a list of all of basically the control files from all the different packages, right? There's some more information in there, but effectively that's what it is. So a lot of the different things we saw about is version, package name, they're all in various different chunks here. So here's one chunk for one package, here's another chunk for another package. That's basically what a feed is, right? Now, the way that this gets built, where the packages live in the same directory as a feed, is one way to do it, right? Sometimes we refer to that as an inline feed, but it's not the only way to do it. We'll actually see another way to do it here in a little bit when we talk about package installers. All right, so I've created a feed. All of my packages, I've added it to the same feed, to the same directory, so it added it to the same feed. Now, I want to then have my target computer get these packages, right? So how do we do that? So for this demo, we have a VM that we're using as our target machine. That will hopefully not times. Oh, there we go. We'll go ahead and use it there. So you can imagine this is our target machine, so right there. And now what we want to do from NI Package Manager, so this is NI Package Manager for those who haven't seen it before, is add that feed to basically our list of subscribed feeds. So I'll go to our settings, go to add feed. I'm going to browse to wherever we have that feed. Say it's on a network location or what have you. In this case, it's a folder called network folder feed. We find our packages file and say open and say add. And so now what you'll see is this packages tab, this list just got a lot longer. And now we have access to all of the different packages that we just created and added to that feed, right? So I can also do things like filter by maintainer. In this case, NBA is our company. There's other different attributes you can add to your packages that kind of make them, we call them products, but it's kind of higher level versus infrastructure packages. If you want to kind of filter out the infrastructure stuff, you can do that. And now you're left with a list of packages that you can install that on your target machine. So in our case, we want to install, let's say, again, I just care about step A, and I'm on test station 1. I'm going to install those. And what it's done basically is done that dependency calculation, right? So as we saw in the other diagram, test station 1 depended on certain things, A depended on certain things like the actual main application, right? Which then that itself depended on these different plugins, right? So all that's getting pulled in and going to be installed. So we did all that, cool. It's installed our application. We can now run it, and we saw what we saw, right? So this is the application we built on the development machine. Cool. We can go to our sequencer, we can run the test, we can do all sorts of fun stuff. All right, so now, for a better demo, we'll do that. Okay, so now here we are. We're gonna, maybe I get there and I have to say, all right, well now I want to also do .2. So I go back to my list of packages, and I'll install .2. It doesn't need to install all those dependencies anymore because they're already installed. Install it, cool. I go back to my executable, I can refresh. Now I have .2, right? I can run that. Okay, so cool. We've done our first initial kind of deployment, and I can get out of this now. But I'll just go back. All right, so now here I am. Now I need to make an update to my application, right? Maybe I want to change some constant, like Alan was saying, or some color. In this case, all I'm going to do is go to one of my plugins. Let's say the configure hardware. Sure, let's do that one. Open up the VI that's in here. I want to say, I'm going to change this text to say select my hardware for whatever reason. Say cool, save it, close it. And now I want to rebuild, basically I want to rebuild the source distribution, and then I want to rebuild the package. Now when I rebuild this package, because it's already configured to re-add it to this feed, it's going to automatically update that feed. The same feed that my target machine's already subscribed to, right? So, all right, I'm going to actually build both of them together. Build that, build the package, cool. You can actually go real quick and look at my feed again. You'll see that the new version of my configure hardware has been put down here, version 4. You can look at the packages file again, just reload it. If we go down to the very bottom, we'll see that version 2004 has been added to this feed. And then we can go back to our target machine and basically say, all right, well, I know that I have an update. I'm going to go to my updates tab. I actually need to refresh. So I'm going to hit F5. It'll look at that feed, see if there's any new packages in there. And eventually,
That you're looking at all your feeds.
Oh,
Did
yeah.
you say you've had internet connectivity?
Yeah,
that's going to take a little while.
As my wireless adapter is kind of broken on my computer, so.
All right, we're going to get back to this. But essentially, that would be how we would then go through and install updates to that new package through that feed. Any questions on that? Yes.
Within our own application, are we able to, via command line or anything else, call out to the package manager and let the user know there are new packages available from that?
Yes, and in fact, that is not an uncommon thing I've heard a lot of people do as part of their executable at launch or at some periodic time. There are CLI commands that you can call. Alan has a kind of a informal LabVIEW API that effectively wraps the CLI to do things like check feed, check for updates, that you can then present some UI to tell the user to go update or do things like that. Absolutely. Any other questions? Yes.
How do you go about building
There is an add-on you can install through an IPM. So if you have I think it starts with 2014. I think 2014, 15, 16, 17, and 18, there's an add-on that you can install like using this thing. Or is that
Are you talking about the LabVIEW API plugin?
No, the application builder for Appendix.
Oh, yeah.
Alright, let's see if this, yes, alright, so it has not found this thing. But it did find the update to this package, which is the configure hardware subpanel package that we just made. I'll install the new updated version of it. Cool. I'll rerun the application. And now I have selected my hardware instead of your hardware. Right? And it looks like you have a question.
Can I downgrade?
Currently, no.
So through the NIPM GUI that you just saw, you can't downgrade, but through the CLI or the LabVIEW API, you can downgrade.
Yeah. Okay. Keep going.
Sorry, repeat the question, please. Yeah, I was asking, can you downgrade? The answer is no.
Oh, sorry. Repeat the question. The question was, can you downgrade? And the answer was no, not through the GUI, but through the CLI first. All right. I'm going to keep going, and then we can answer more questions.
Can you repair a package?
Not today, but that's could be coming soon.
So the question was, can you repair a package? Today, through the NIPM GUI, you cannot repair a package, but that is coming soon.
Yes. And then the last thing about distributing componentized application using package installer. So this is something that is new to LabVIEW 2019. NXG has been able to do this, I think, for one version before. But essentially, you can also then create not just a feed, but a package installer that effectively is almost like a little wrapper around a feed. So let me show you what that looks like. We've already built it, so I'll just dive into it. It looks like this, right? And so like I said earlier, one way to do a feed is to have the feed package, the feed manifest files along with the package in the same directory, totally valid. Another way to do it is using a pool. So you'll see we have a feeds folder that has two feeds in it. One is actually for package manager itself, right? Because the other thing that comes along when you build a package installer is you can then run that installer on a completely clean machine. It'll install package manager first, and then it'll install your packages that you wanted to include. So that's what the package manager feed is, and then it has the feed that you have for your application, right? And all the packages themselves actually sit in a different folder called pool, and these are all the packages that you need to install package manager in your application, right? So you can see this sort of architecture. In fact, it's something that kind of we do internally at NI, where we have our feeds in one location in a pool of packages somewhere else. That way we can have multiple feeds that reference the same package without having to have copies of that package in multiple places. Right? So if that is something that you're interested in, that's something to think about. But essentially, like I said, you would run this install.exe, it would install package manager, and then it would install the packages associated.
Can I lend some weight to why you might want to have multiple feeds? So you might be building a non-released version of your software, and in order to release it, you just list it in your released feed versus your staging feed. Well, as time goes on, you might want to archive. So you want to move from one feed to another, but you're not making copies of the NI package, you're just moving where it's registered.
Right. Yep.
And so to recap what Chelino just said, was basically he was giving the scenario where you might have multiple feeds. One feed might be your released feed, so all your end users might subscribe to that release feed and get those packages. You might have another staging feed, right, pre-release for maybe the developers.
All right. So that's basically that. Like I said, it'll install package manager and then your package and any of the dependencies that you needed from your package. Yes.
So how, I'm trying to get my head around, are you then defining the feed for the package before the installer? So how?
You can define them. Actually, I should have showed you that. My apologies.
I'm just thinking that how does sort of like chicken and egg, how does that work if it's really distributed to a fully separate machine? It's referencing the file, you know that file is.
So the package is, the feed in the package installer is separate from the feed that you defined here. Sorry, the question was, if I can rephrase it a little bit. When you're defining a feed here, how does that relate to the feed that exists within the package installer? Essentially, those are two separate feeds, right? And so you would define your package installer basically here by just saying create and then give it a destination. So it's all part of the same build spec. You can create your package, a feed, and a package installer all the time in one go if you want to.
Right, so just another way of clarifying that, for the package installer, like the feed stuff that he just showed you in the packages in the pool, that's all like inside guts. For you, like you create a package installer, it's going to handle that through feeds and packages, and now you kind of know what that does, but really it's invisible to you or the user.
Right. Yes.
So right now, what I've done for several years, because I have clients that are at sites where very slow internet, I actually usually create 2 installers, one being all the LabVIEW drivers, app drivers, etc., that they run once, pretty much never update, and a second one for solely for the EXE, so it's small, light, easy for them to do. Am I able to combine that into a single packaging feed? Do I have an installer for 2 feeds to do something similar? How does that map, or is it answered in some of the links you sent?
So Aaron was just kind of talking about, well, this Aaron was talking about, well, he has, traditionally right now, he's got a installer for kind of the core components like runtime, drivers, and stuff like that, and he has another installer for his applications, right? And that's the way that you were able to kind of componentize that, right? So if you wanted to keep that same model, you could. You just create 2 different package installers, right? And you can still distribute these standalone installers, right, to go to offline machines or whatever. Another option, so I have a link for this. You could host your feed like on the cloud, right? So there's step-by-step directions that I have that you could put this on Amazon, for example. And then once you have it in the cloud, you can have your end user subscribe to that, and then at that point, everything's a component, right? So if you update any of that, they can download the whole thing, and if they're downloading the application that depends on the LabVIEW runtime engine or DAC, whatever, it's going to download that as well and install it. So you can really componentize the whole thing. Or if you're distributing to these offline machines, then it probably still makes sense to have 2 different package installers.
All right, keep moving. So I can do this next part. The other thing, last thing to mention real quick, and then I'll get to your question. You may hear this term thrown around a little bit, an online package installer. So actually, if you go to ni.com/downloads today and hit, find LabVIEW or whatever software you want, hit download. What you'll download is what we call an online package installer. Essentially what this is kind of by reference. You can think about it, right? The packages themselves don't exist in the thing you just downloaded. It's just basically pointers to the feeds where you can find those packages, right? Now LabVIEW NXG, I will give a little tease for that, can do this to some extent as well. So you could build a package installer from LabVIEW NXG that includes basically pointers to the dependencies of your application. So you build an application, it depends on DACMX, the DACMX runtime, and you build your package installer. All you're building is your package in that package installer plus package management packages in that package installer, but DACMX doesn't exist in that package installer. When you run that package installer, it'll say, all right, go download DACMX from the internet. Again, this really only works for online cases. And then install it at that time, so your package installer can be small.
What if you already have DAC installed?
Then it won't install it.
Will it download it again?
So the question
It won't
was,
download it again either. Good question, Kid.
yeah. So the question there was, well, what if on that machine DACMX was already installed, right? So then Aaron's answer was basically, well, that's good because then the lightweight installer didn't include the DACMX install files, and it's not going to download it either. So.
Yeah. Yes, you got a question.
I have customers that have various versions of all the developers, and sometimes all the way back to 7.1 and others as a bugs. Can I componentize and put a host a local feed that includes, like we talked about, effectively what you have on the top? That can I pull down from those packages that host the locals is there help with that going?
Technically, yes. So there are some, I think it's a white paper or KB that talks a little bit about, I don't know if you have a reference to it, how to download NI packages from NI. It requires some CLI work to basically point it to the feed, and then you can run CLI since download, and then you can archive those on some server or whatever you want. Alternatively, I'll throw this out as an option. Starting with this year's 2019 software stack, or obviously everything's coming out through packages. As I talked about earlier, when you go to ni.com/downloads and you hit download, you get this online installer. There's also an option to download what we call the offline installer, which does contain the package. And theoretically, if you wanted to, you can go to the pool, just like we saw in this package installer, and just take the packages from there as well. So there's a couple different ways to do it. you know, it's not maybe not the cleanest or most streamlined way, but there are ways to do it. All right, I'll hand it back to Al.
Yeah, so like the package installer that Aaron was talking about earlier, what he described that you created, and you can actually dig in there and see the packages. That's exactly what all the 19.0 software is going to be. So if you downloaded the offline installer for LabVIEW 2019 today, what you would see is install.exe, pool subfolder. If you just double click that pool subfolder, those are all the packages for 2019. Same thing with Appendix 2019 and all that stuff, or 19.0. Okay, cool. So we got about 15 minutes left, and let's see. So we're going to talk system link, and then some getting started. So what I'm going to do before I dive into my section is that was awesome. There's a lot of great technical information that you guys just heard. What I want to do is just do a quick recap and kind of boil it down to like the simple things you need to know. So now you know the details. Let's dive back into the high level. Okay. So the thing that Aaron just stepped through for us was how do you do this workflow with NI Package Manager in LabVIEW. So step number one, build packages, right? So you saw that. He went into the LabVIEW project, create a package build spec, define it, build it. You got your package. And in fact, if you want to distribute it to like a feed, you might put it on a network feed inside your company, and then you could just go to the package build spec, go to that feed category, and automatically add the package to the feed. Okay? So at that point, you built your packages, you've automatically added it to this feed. Now imagine that's like / my company network. Now you go from your development computer, you go to your target computer. Your end users would just open up Package Manager, they would go ahead and register to that same feed that you just created. And then once they register the feed, they can go to NIPM, look for the specific application they want. They can maybe filter it by maintainer or group or whatever, and then download that. They click install. By virtue of dependencies, which Aaron said was super powerful, you select the top level thing you want, it'll figure out everything else you need, and if it's already installed, it'll be efficient about it and not try to reinstall. Right? So now that's what happens. And then for you as a architect or developer, you're gonna say, well, you know, I don't write perfect code every time. Maybe there's a new feature. Maybe that's a more positive way of putting it. So maybe we have a new feature. I'm gonna go edit my stuff to add a plugin or maybe modify an existing component. Click build, it auto adds it to the feed. Maybe you, whatever mechanism you want to let people know about updates, whether it's programmatically through your application or through email, then the user just says, hey, there's an update available. Let me go install that update. Boom, I'm done. Okay. So that's kind of like the recap of everything that we just said. Okay. Any questions on that before I kind of step through the system link scenario? I'm sure those questions come afterwards. Okay, so let's talk about system link. How many people have been to a system link presentation so far at this NIWeek? Okay, so a couple. There's still more sessions. I think there's maybe a total of 8. So there's still some more. So there's more time to get to it. If you want to distribute a componentized application using system link, let me walk through what that workflow looks like. So I'm not going to talk too much about what System Link necessarily is. One piece of it is you can use System Link to deploy your application. So you can mass deploy and do a push from like me as an architect. I can say like I've got these packages, maybe this set of packages at a specific version, which might be called a state. And I can say, well, to these 5 machines, push it over there. Or these 100 machines, update all these 100 machines with this specific software, set of software at these specific versions. Okay. So it also does other things like test data analytics and a bunch of other cool stuff that you can see in other presentations. But the workflow for deployment would look something like this. So step number 1, build your package, which is kind of the same thing, exactly the same thing we just talked about. And then you can distribute that package on a system link feed. And LabVIEW 2019 makes that even easier because when you add something automatically to a feed, you can actually, the same setting, you can say automatically add to a system link feed as well. So now you've got your package, you built it, you put it on the system link feed. The system link, there's also kind of a GUI for a feed manager. So within system link, you can create feeds through the web browser. You can add packages to feeds, remove packages from feeds, and all that stuff. That's all built into the system link. And optionally, you can create a state. So this is something I hear a lot from certain customers. There might be a use case where you're saying, you know what, it's not necessarily just this package that I want to distribute. What I'm really distributing to my end user, what they care about, is actually the set of packages. So the end user might be saying, like, I need to test this DUT. Well, you as the creator of these components know that to test that DUT, I want you to have package A, B, C, D, E, F, G, and it needs to be at version 2.0. This one needs to be 1.5, and I want that exact version. What you can do in System Link is you can go to you can either create a state and define it yourself, or you can actually go to, maybe you have a golden system that has the exactly correct set of packages and versions, and you can say create state from that system, and then you have that state from the system, and you can even add or modify it from there. Okay. So at that point, you've got your packages in there, you've got your states in there, and then you can say, I'm going to push to my clients. So you as an administrator, you can say like, okay, well, I'm going to say this state or these packages, I'm going to push it to these 100 machines. Or if you want for your use case, there could be end users where you say, hey, these end users have the ability to install to their machines, and that end user would just open up a browser, select their machine, select which state or package they want, and then through the browser install it. And then the browser would basically, talk to system link and go through, that client server stuff and get that stuff installed on that particular machine. So for this use case, how many people in the room is that something that might apply to you or something that you're interested in doing? Okay, if so, just come back to come talk to me afterwards, and we can talk those details. All right. All right, and you can for everyone else, you can go to ni.com/systemlink, and you can see some details there. Or again, you can go ahead and contact me as well. So let's do a recap / quiz. So this first question: would my application benefit from componentization? How many people in the room feel like they can answer this question or have the tools to answer this question now? Okay, so most of the room. And for y'all, if your boss said to you, you know what, make me can you architect a componentized application for me? At an architecture level and just conceptual level, how many people feel comfortable with like trying to break that down now? Okay, decent amount of people again. And then the last one, second to last one, how many of you would feel comfortable building a componentized application like in LabVIEW? So less hands, but hopefully with the tutorials and links that I sent, you'll be able to get there and have some step-by-step directions. And then lastly, the fun part of the presentation: how do I distribute my componentized application? How many of you feel confident that you could do that with packages today? So probably some people would mess around with it. How many of you don't feel confident, but if you feel like you have maybe the right places to go to or right people to ask questions to for this? Okay, cool. So that seems like the other half. Okay, so what I'm going to do real quick, and I'm just going to talk about the getting started experience. And again, this is in the slides. It's really meant for you guys to be able to get started easily. So in the slide deck, when you guys want to download this afterwards, step number one, well, install NI Package Manager. So if you install anything like in the May 2019 release and some before that, it's actually because our software relies on NI Package Manager to like under the hood to install. NI Package Manager will probably be installed by default. But if you're on an older machine and you still want to use this, you can just Google download NI Package Manager, and it's going to have its own download page like everything else. And actually, I think the download page is a little stiffer than that now. So now that you've got Package Manager on your machine, you can configure NI Package Manager to show the package and feed management tools. So some of the stuff that Aaron showed off, that's because we don't just allow that to any default person who installed NI software. We kind of hide that behind the settings. So if this is something that you want to do, then simply go to Settings and go to Feeds, and then you can say Show Available Packages and Feed Management Tools. Okay? That'll unlock all the stuff that we showed in this demo. You probably don't want the average end user just willy-nilly doing this stuff, right? So in terms of the support of being able to create a LabVIEW package build specification, if you're using LabVIEW 2018 or later, you don't have to do anything. The package build spec is already in there. But what we've done is, if you want to use LabVIEW 2014 to 2017 and you still want this capability, you can actually go to NI Package Manager, go to the Browse Products, and if you look for LabVIEW Package Builder, if you click that and install it, it'll install support for LabVIEW 2014 through 17. Okay. And then lastly, after you build your packages, if you want a little bit more configurability, if you don't want to just add every single package you build to a feed automatically, and you want to determine which packages you want to add, which packages you want to remove from feeds, or create feeds, remove feeds, all that kind of stuff, I've got a tool. It's a feed manager tool. And you can go to either just VIPM and then search NIPM. You'll see the feed manager, as well as the NIPM API in LabVIEW. So really, this is if you install that, then you can just go to Tools in LabVIEW, go to Feed Manager, and then you get the GUI where you can create new feeds, you can add packages to feeds, like that. And really, what I installed is just a VI. So if you want something, add more functionality or you want it to look different, just open up the VI, change the source code, and then you're good to go. And I think in the help, it also has a GitHub link. So if you do something really cool and you want to share it back to the community, go ahead and submit the pull request thing for GitHub. And then also, same thing with the NIPM API. Everything that we talked about today, installing, upgrading, listing feeds, all the stuff that you saw the NIPM GUI do, you can do that programmatically too. And what I've done is I've created an NIPM API. It's kind of unofficial, just to give to the community, and you guys can also iterate on it if you want. But it gives you the option to do really cool things, like in your application when you launch. Maybe it programmatically checks the feed, sees if there's any updates, and then if so, it offers the user the option to go ahead and upgrade right there. So I've talked to some customers who do that, and it's pretty cool stuff that they can do. And again, that one you can contribute to as well if you want. And then I think I already went through the recap, so we're good on that. And we got about 4 minutes left. So lastly, I've included some additional resources where, so we focused really on the distributing side for componentized applications, but there's a lot of really cool stuff on the first half that I didn't talk about, where just good practices for building an application. So this is cool stuff like how do you create a cool splash screen, launcher screen, cool graphics and stuff like that, and also deploying and licensing and stuff like that. So I've put these into this presentation as well. So if you're interested on that stuff, definitely click on that. I endorse these presentations. And then also LabVIEW Application Builder and continuous integration. That's another part of deploying, right? So everything I showed you was pretty cool technology. You can even automate that further with CI. So this is slide 2017, so there's probably more up-to-date stuff on continuous integration. And I'm sure there's some better sessions here at NIWeek this year. So just wanted to say, like, these are kind of on the same. If you're looking at this and interested in this, you're probably interested in these two things as well. So I think that's it. And the appendix, which I won't go through now, but this call goes through more details of like, hey, what do you do with the EXE? How do you do this, parent class thing, PPLs, all that stuff. So that information is in there as well as the links. So again, if you forget everything today, maybe just take a picture of this. Go to bit.ly/MIPKG. Everything I have is on there, as well as more details with the step 1, 2, 3, 4, 5, 6, 7 instructions on how to do it.